So yeah, I should actually should have an OWASP logo in there because I'm actually representing OWASP today. And I wanted to point out also about myself the picture that's on your package. So that's how I used to look like before the U.S. elections. Now this is how I look now. I gotta work on my jokes. But anyway, so yeah, so my name is Kuai, and I'm actually my title changed. So I'm a global lead software security engineer for Intel Security. Within Intel Security, which used to be formerly known as McAfee, we still have a team called Foundstone, which provides professional hacking services for our customers. So basically, my background is on software development and breaking software. And when I'm not wearing my Foundstone or Intel Security hat, I'm basically contributing my time to OWASP. I've been with OWASP for more than a decade. I used to run the chapter in one of the states in the U.S., Minnesota. I was one of the ones that introduced Bruce Schneier to our group, and I worked on the education committee for a while. And now, lastly, I'm basically a project co-leader for the SAMM, the Open Software Assurance Maturity Model. And before I joined Foundstone, I actually used to work for Cigital, so I was very glad that Martin brought that up because I'm going to talk a little bit about the model that he mentioned in OpenSAMM, which is basically very similar. So I'll talk a little bit about some of the challenges that we have we have faced. I want to introduce the model using a case study, and then I'll provide more information into how the model works and all those kind of things. So I already told you about me and my company. If you ever seen these books, Hack and Expose, some of us are the authors of that. And then we do a lot of stuff in the security community, so they're just going to skip over that. This picture actually represents when I talk to a lot of the people that call us or ask me to kind of help them with developing software security programs. This is like the main common thing that I see when I talk to them, and it basically is implying that most people that are trying to implement a software security program within their organization, sometimes they feel like they're herding cattle, right? Or herding cats, I should say, like meaning that it's very hard, right, to get everybody to go in the right direction. And in my opinion and in my experience, if you feel like that, and I saw one of the slides on later talks, and there's something similar to that, so I want to make sure that we understand this because it's really a common theme between among people that are organizations that are trying to implement software security programs. In the idea being that if you feel that your response is this, you're not getting much ground, much progress, is because you're probably doing something wrong, right? You don't even have a very good strategy. And it's a very complex problem, right? It's a people, process, and technology problem. We talked about some static analysis tool, automated tools, so not to say that they don't work, they do work, but they have to be implemented with some process and coordination with other activities in order for that to work. And you got to be able to measure, and that's where BISIM also comes in, these type of maturity models. It is also about changing organizational culture, organizational behavior. And that's why I'm very big fan of this type of maturity models, because it's the only tool that I have used in the past that has allowed me to change organizational behavior by introducing this type of activities one step at a time. The other challenge that I hear from people is that, most of them that are not implementing a program, they usually focus too much on the tactical aspects of security, right? So they call us, for example, to do penetration tests, to do core reviews, to do architecture review or design reviews, so their applications or their systems. And then like a year after, they call me back again, and we do the same thing, and we find the same issues again. Whether they're in different instances or different systems, but we find the same issues over and over again. So it's not really, in the short term, it's not very cost effective for them, right? And these type of maturity models are actually very cost effective because you have a strategy and you're measuring to ensure that you're actually making progress, that you're actually being effective. So, the model. Very similar to what you saw with BISIM, as you can see. That is because BISIM was a fork of OpenSAMM. So OpenSAMM was developed by a gentleman named Pravir Chandra, who used to work at Cigital. I used to work at Cigital with him. And right after he left Cigital, he actually opened this project, opened the model, and Digital decided to just change the name and change some things, and but it's basically a very similar idea, very similar approach. The model, when we created this model, I wanted to mention this, it was based on what we saw on the ground. So we were doing core reviews, we were doing pen tests, and then we were seeing that some organizations, some of them were doing pen testing on their own, some of them were doing core review on their own. So we started to see a pattern. And based on that pattern of fundamental basic steps that most organizations should do to build an application security program or software security program, we build these functions and the practices that you see on the screen. So the main functions are, or domains, whatever you want to call it, are governance, construction, verification, and deployment. You can see that this is very different from BISM. Governance basically describes all the practices that entitle how to govern a software security program. How do you measure? What is your strategy, right? So to give an example, for this particular case study, we work with a company that it was a retailing company, and they have top 10 applications that basically handle credit card information, and they wanted to become PCI compliance. So that was basically our strategy at that point, to focus on those top 10 applications and really understand how we're developing these top applications, and then basically build a roadmap, identify the gaps, and build a roadmap into how they could implement security activities and build secure software from there on. Regarding metrics, so we chose metrics like how many bugs we find through code review processes or quality gates, pen testing versus design review, in addition to success metrics that I will discuss further during the presentation. And then you see things like policy and compliance. So PCI was being one of the main drivers. So I'll talk a little bit more about that, how we kind of align the activities to make sure that they were PCI compliant. And then education and guidance is all about training and guidance and making sure developers have the right tools in order to inform themselves and become more of a defensive programmer. Construction talks about how to build software properly, like securely, right? So you see threat assessment, which is basically the practice that describes how to do threat models. According to the model, it describes that you got it. That's something that we talked about. I know Martin mentioned that some organizations that he measured, they don't seem to do this, but this is one of those things that we actually help and try to inside organizations to do, because it allows you to understand what your attacker profile is, to understand the who, the what, and the how, right? Who are the attackers, whether they're internal or external. What are the assets that we want to protect, and how those assets can be impacted by certain threats, right? So that's why it's so important. The next one is secure architecture, that talks about how to build. It's a practice about how to build a secure architecture, right? So, for example, to give an example, if you are an organization that have different web applications, web properties, and then you decide to buy a single sign-on system, that's a secure architecture guidance that we will provide. We would say, like, hey, make sure that you use a single sign-on to get all the web applications, all the applications to sign in through it, through basically authenticate through that system, instead of reinventing the wheel for each single one of them, right? So you want to centralize, or even using like application security libraries, like I don't know if you heard of OWASP, ISAPI, Enterprise Security API. So basically it's a security library that you can incorporate into your own code and allows you to encode, to do all these kind of things like encryption and whatnot, make it easier for the developer. And then security requirements are basically security requirements that you give the developer to ensure that they do authentication the right way, like making sure that they're using the STP only cookies, attribute for cookies, or as a secure attribute to ensure that cookies go through a secure channel, just to give you a basic example. And then verification covers everything about testing the software, right? So once you have built it, you want to review, you want to perform a design review, so you want to review the specs requirements of the application against the security requirements to ensure that the developers are doing the right thing and they're following the right things. And then code reviews and security testing basically is self-explanatory, but it's reviewing code and pen testing. And then deployment covers all the activities or the practices for once you have the code built and verified. What happens after that? How do you deploy it to the right environment? So here you will see things like environment hardening. Excuse me. So that talks about like ensuring that your environment is hardened, like that you have a hardened baseline, like a hardened Linux environment, that you have all the right firewall configurations. Basically everything has to do with containing the environment where you will deploy the code. And then vulnerability management talks about managing your vulnerabilities, so you're having a process around that. And then operational enablement, which actually we changed it recently through the project I think we call it operations security or something like that. But anyway, it's the same thing. It covers everything about like what happens when you deploy the code, any instructions that you want to give to the operations team, sort of like DevSecOps, including change management controls as well. So for each of those practices, 12 practices similar to BISM, for each of those 12 practices, we assign a maturity level, 1 to 3. 0 meaning that there is non-existent, so basically you have nothing in place. 1 means that you sort of have activities A and B for that particular level 1, which means that you're kind of adapting to security activities. 2 means that you're sustaining, so they're a little bit more advanced. And then 3 is like mastering those activities and actually scaling them. So that here's where we want to see our customers doing. In this case, for this particular case scenario, we were working with a team that started building continuous integration systems through basically all their code through CI and having a static analysis tool in the process. So we will use the automated process for the low-hanging fruits and then follow up with a manual review for those more advanced areas to check. Any questions on that? No? Did I lose you? Martin? Sure. So it hasn't changed in many years. I mean, it was created in 2006. But there's a reason for that, in my opinion. I don't see that many things to change, to be quite frank with you. And the changes that I have seen recently by the project team have been like very minor stuff, like maybe some activities here and there, like how the activities are actually implemented. And also some of the name changes for the practices, like operational enablement, that people thought it didn't make sense. So yeah, there's not much. Okay, so this is an example of starting a metrics. I think I mentioned this, but this is kind of to give you a perspective of what the model. By the way, this is if you go to opensam.org, you can download the PDF. It's also open source project. Basically, it has Creative Commons licensing, so you can download the PDF. It's a 96 pages long PDF, and then you can see basically all the details that it provides, right? So you can see the objectives 1, 2, and 3 for starting your metrics, the activities A and B, and then it provides sometimes like success metrics and what results, what you should expect after that those objectives have been reached. Excuse me. You also describe something that BISM, in my opinion, doesn't have, and it's more of a guidance on how you do an assessment. In a Foundstone, we use, when I help our customers, I call it software security maturity assessment. So it's a service that I provide, or that we provide. And for this particular case scenario, we work with this retail company. I mentioned that they wanted to be PCI compliance, and they didn't have any type of activities in place to be, and you'll see their scorecard. It's a little bit sad. In fact, I used to call them -1 because they were they were going to a level. It seemed like they were going backwards at some point. But our methodology in terms of doing the assessment, basically in a nutshell, we have a discovery phase, analysis, and audit, and a checkpoint. So the discovery phase is very similar to what Martin described with BISM. So we go on the ground and we interview like the stakeholders of software development. So like the director of development or the development lead, the QA lead, the software architect lead, and we try to understand how they develop software, to understand their practices. And we also ask for artifacts like documentation, procedures, anything that they can have that serve as evidence and documentation for us to understand further how they currently build software. And after we've go through that stage, through that phase, we follow up with an audit, which I think is very important to collect that type of evidence, right? So we do a penetration test or a code review or sometimes a host configuration review. In this case, a scenario, when we work with this company, we basically did all of them. We did a pen test and code review and also a host configuration review to understand their environments. And at the end of the audit, we basically provided a technical report that provides all the scorecard, the maturity scorecard, all the gaps, and also some guidance and a project roadmap on how they can improve their maturity levels. So through the process that I just described, I basically broke down the results into people, process, and technology gaps, right? So in the people gaps, I didn't have anybody on the software security side. they have no strategy whatsoever. So they were basically, because of PCI is basically what triggered this. They wanted PCI. I don't know if you're familiar you are with PCI, but PCI requirements 6.5 and 6.5.1 through 6.5.9 describe all secure software development practices. Like make sure that you are aware of OWASP top 10 and you have a secure development life cycle and whatnot. So that's why the main reason why they started to go down this road, and I was brought in as a consultant to help them out. In the process point of view, they basically like all the processes that you saw on the model, all those practices, they were non-existent. So they don't have any secure architecture and no design review, none of that. The only thing that they had was that they were running a automated test every year to see like sort of like their poster. But then what they would do is they would literally take the results of the scan and run it to the teams and freak them out and say, hey, I found 100 high vulnerabilities. And then they will freak out. They have no idea how to proceed, how to fix the issues. And some of them were most of them, I would say, they were false positives. So because of that, I gave them a plus sign. Plus meaning that they're in between maturity levels. They also didn't have like any of guidelines, like standards for building web servers securely or database security processes, none of that. There was no change control, nothing. They were literally basically, and I'm talking about an enterprise worldwide company. And they were basically, developers were logging into the production environments, programming the features that they would get from some of their customers, and then automatically deploy them to production, right? Because they were coding it right there on the system. So then the thing would crash, and then they would start pointing their fingers at each other. It was the Oracle team, or it was this team, or it was other team. It was a complete mess. And I don't say anything else because I'm being recorded. But yeah, so also on the technology side, I gave them some, like I said, plus sign, but they didn't have the tools. They have, like with the .NET framework, there's certain tools that you can use, like FSCAPs and also cat.net, for example, if you're a .NET developer. And these are tools that you can run when you build the software to ensure that there's no cross-site scripting or SQL injection easily or visible on the code. Like the really low-hanging fruit type of things. Those tools are actually free. You can download them and you can execute when you build your code. So they didn't have any of that stuff. They were not even using open source things that are out there to help their development processes from a secure perspective. So this is an example of a sample of the scorecard that we provide on our reports, right? So here you can see all the practices on this side, and then we have a start of the engagement, right? So you can see the 0+, and this is basically where they were. And then we try to map the activities or maturity levels that we try to recommend moving forward. So we break the projects and the roadmap into phases: phase 1, phase 2, phase 3, phase 4, and these are the recommended maturity levels that we want them to achieve. Yes, you have a question? That's a good question. So each phase usually takes about 2 to 3 months. Yeah. Yeah. It's a big company. It takes time to change behavior like that. It's not overnight. You think it's fast? That's funny. Okay. Yeah, that's funny. We should talk about that later. And so, yeah, and then this every time we have a project phase, so we provide these checkpoints. So we try to basically see where they're at the end of that project phase to ensure they're actually moving forward. And if they're not, then we go back and revisit like what is not working, right? If it's not the training, or if it is the code review, or maybe automating tools, we'll try to figure that out at that point. And then for this particular case, initially for most of our customers, I try to break the project into those phases, and I give them a theme. So like the discovery and some of the things that we're trying to do, right? Planning and awareness, which is like usually when we're building something, we want to have more planning, more awareness, socialize. So we have like socialized sessions where I talk about software security risk and all those kind of things to kind of socialize the ideas of what we're trying to do, and everybody understands what to expect by implementing this type of maturity model and programs. And then the rest you can see: training, testing, infrastructure, and architecture. This is where we kind of go back and look at infrastructure and architecture. And then at the end, in this case, we kind of went back into the governance and the operational security, operational enablement, to see that those areas were taken care of and they were actually making progress. And this is basically like a timeline. So one of the things that I learned through my experiences, since I'm basically communicating with C-level or senior executives and the people that basically have the money to support this type of projects, they love this type of things. They want to see nice colors. They want to see timelines, so we're getting there with where we at. So you see the green is the stuff that we've done, the blue is the stuff where we at the moment, and then the red is where, you know, the future stuff that we want to do, right? And you can see some of the success metrics here. I know if it's kind of hard to read, it seems. But here you see, like, it should say 80% or more code review activities performed for the top 10 applications. So it's an indication that we're actually improving those areas and those activities. Similar for like testing, security testing, and also education and guidance. So we have this type of metrics, success metrics that we refer to that is described by the model, to know, you know, whether we're a certain percentage or plus in terms of those projects and the people that are involved in those projects. And by projects, I mean an application that is part of the application risk portfolio in a scope. Excuse me. And then, so for phase 2, we have the awareness and planning. So this is like some examples of some of the activities that we, of how we implement some of these activities, right? Like education and guidance, policy and compliance, strategy and metrics, which I mentioned some of them early. But from an education point of view, so here's where we started to do a little bit more of like brown bag sessions. So we have like 50-minute brown bag sessions where we will talk about certain topics, and then we will break this down into groups. So like developers will have top 10 PCI sessions versus like the product managers or project managers that will have sessions on application security risk 101, which are more high level, right? The other ones are supposed to be a little bit more technical for the developers to understand what those issues are and how to recognize them on the code and how to fix them, most importantly. And then we also try to, at this point, to build like a knowledge base of information to kind of push those security requirements and guidance that we're providing to the development teams and all the stakeholders, so ensure that it's centralized and anybody can have access. Well, the people that are part of the project should have access to it. And from a policy and compliance perspective, at this point we were also pushing for a little bit of building a project audit practice at that point, because they were PCI centric. And one of the things that we did, and too bad you cannot really see this slide, but literally what we did was, and I did this with one of the OWASP summits, I gathered a few guys that do PCI compliance and a few of CISOs, and what we did, we started mapping all the PCI requirements, which are basically right over here, PCI 3.0, PCI DSS 3, and we basically map the maturity level objective that you must achieve in order to meet that requirement. And this is one of the questions that I get a lot. People saying like, what about ISO blah, 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 or COVID or this and that? And like, yeah, I have nothing against them. I mean, they're big, long things of things that you're supposed to do, but nobody does them the right way, or they don't know how to even start. So this is where the maturity models come in, because it gives you a step-by-step process. You know, the idea that Praveer talks about when he developed this is you want to crawl before you can walk and walk before you can run, right? And in terms of compliance, this is one of the things that we do in order to make that effective, right? So at this point you want to align those requirements to ensure that the activities are actually matching what you should do. It's really more of a risk-based approach, in my opinion, as well. So phase 3 training and testing. So we did a lot of testing in here, as you can see, and we started doing a lot of like code reviews. So the top 10 checklist kind of thing, that's stuff that we do as well, you know, for the basic programs. We start writing based on the things that we saw in the audit, by the way. So we don't just build some top 10. We don't go to OWASP and download the checklist right from there and get handed to them, right? So what we did is, based on the results of the audit, we make sure that those vulnerabilities that we saw through the audit, that we put them as part of the checklist, because we want to tackle those items, high-risk items first, and then evolve as we start maturing those practices. Yeah, no, the score review and all that stuff. We established also an informal response team, which they didn't have at the time. Oh, God, this slide looks horrible too. But this is supposed to be a cross-functional chart. This is another thing that we do, that we did for this particular case study. But basically, what we're doing is we have on this lane right here, we have the software security group, we have the QA team, we have the development team, and then on these columns we have new, active, resolved, and closed. So these are basically the status of a security bug, and the process for bug remediation is described on this playbook, that we refer to them as playbook. But the idea is to basically build the the process on a diagram like this, so everybody knows what they're responsible for and understand what to expect and what the process is. So here, very quickly, so here is when we enter the requests. In this case, we use TFS, Team Foundation Server. I don't know if you're familiar with it, but it's good for application life management for if you're a .NET shop. So we use TFS to request code review process or code review practices or quality gates, and that will be assigned to one of our software security engineers. They will pick up the request. They will do the code review. They provide the results through TFS, basically, and then bounce it back to the team so they could understand what the issue was and work on a code fix for it. And then once it was fixed, then we will verify that the fix is actually working. And if it did fix the issue, then we will send it to the QA team, so the QA team could perform like functional tests or regression tests to ensure that nothing got broken by that fix. And then finally, once nothing was broken, we were able to know that, we would literally just close the ticket after that. So it's a very general process, as an example of a good way to kind of socialize those type of processes, which is key in order to ensure that people are going on the right direction. Remember that first picture, right? And then lastly, on this phase on infrastructure architecture, actually this is one before, but here we start implementing the threat assessment or threat models practice, and I'm going to jump right into it. This is actually taken from the OpenSAMM handbook. And literally, we started working on this area right here, so identifying, understanding all the threats of the organization per individual projects per application. And how does that look like? So that it looks sort of like this. So we basically map all the use case scenarios, try to break the system into pieces or components. So here you see, this is not the best example, but it should give you an idea of it. But here you can see basically there's a client component, there's a server component, there's a cluster, there's several pieces here, including a database. And what we want to do is to understand how the data flows through the system, through all the components, understand the trust boundary, who are the users, again, going back to the who, the what, and the how, right? So at that point, once we have that understanding of it, then we have this next model, which is basically the abuse case scenario. Martin was saying that nobody does this. Well, at least the people that we work with, we tell them that they should do this, and we work them. We build their practice so they document this stuff, because this is very important. And here you can see basically the attackers, whether internal or external. If you have the report, it's not visible here. But the idea is to basically highlight where the threats are, high, medium, and low, right? As you can see here by the colors, and then see what kind of attacker, whether it's internal, external, and what kind of assets could be impacted by that particular threat. Yeah, Martin. That means the number of threats that was identified for that particular component. And then finally, 5 is where we kind of went back and looked into the governance aspects of it to ensure that that the strategy was still working. Whether we're still working with 10 applications or we should move on with 5 more, or change the measures, the metrics to measure our progress, etc., etc. And work also in operation enablement. So we worked very closely with change management control to ensure that those activities, like even testing activities, were part of the whole cycle. Which also came into place for PCI, because they do a lot of audit for PCI, and by dumping all these change management control logs, you can see when they were testing, when they were deploying fixes. So it was very easy to kind of tie that they were doing the right things. And then finally, so this is some of the success metrics that we got from this particular case scenario. So you can see some of them, which is on your package, but. Yeah, 80% of code review coverage for the top 10 applications, etc., etc. That's some of the things that we were able to accomplish through implementing this program, picking that strategy for that particular organization. And one more thing that I want to show, so TFS is very nice because you can actually build this type of dashboards, and I found this very useful also for the people that are sponsoring this type of projects, and even the stakeholders who are responsible for pieces of the project, of the model, implementing the model. But here you can see, for example, some of the things that we also measure, like security bug latency, which meaning giving us an average of how many days it takes to fix a high risk issue, medium, and low. And you can see they were not doing so good, right? Like we want to take it for PCI reasons. We want to have high risk issues fixed within 30 days, medium within 60, and low within 90s. So we were basically kind of pushing to get to that. And then we also track like issues that are PCI compliance related, total bugs versus closed, and then like here is a very nice one for the status that I told you, how many bugs are in new, how many bugs are in closed status or resolved status. And I think the ones on your diagram, on the stuff that you have might look much better. Yeah, one question, Martin? Yeah. Never gets fixed. That's a good question. So it depends on what, really the main issue technically. But some of the things that we do, for example, is we work with the compliance team to have a risk exception. And for those lows that we feel that can meet those criteria, then we have a risk exception procedure follow to ensure that whether they accept the risk, or we scrap it, or maybe we should change the risk rating. And the risk rating happens sometimes when we have the discussions after we have the results, and we discuss that with the developers. Once we have their context, then we can discuss whether the risk rating fits the rating or not. And then finally, one thing that I want to fit in before I go. Based on this, on this particular case, which you saw, it was like 3 months per each project, but it actually turned out to be years of work with them. I started collecting more data, so looking at those other areas like environment hardening, for example, right? So based on that, we started gathering data on infrastructure issues, network security issues, even simple like patching, stuff like that. And based on that, I started talking to Pravir, and Pravir came out with something similar to this, which we refer to the enterprise security framework. But basically, we started expanding to other domains. So now we have an infrastructure security, we have a user endpoint domain, data security, and incident management, to kind of use the same approach, but tackling these other domains that for us they're critical for enterprise security. This is actually not released yet, but we will be releasing this as an open source project soon. But it's kind of nice to see how the software, which is the core of everything that we do, kind of help us to extend to these other areas and see the risks that we were missing in other areas because we were just focusing on the software layer for that particular case. And this is a summary of all the stuff that we did quickly. So 3 maturity levels, 4 business functions. It is a good tool to change cultural behavior and implement a software security program in your organization. It takes one step at a time, right? And then we use a case study to kind of show some of the activities that we implement. And some of the key benefits, of course, is what you see, that you're able, it allows you to measure where you're at and what you should be improving. And that's it. Any questions? No? Thank you. Yep. The effort for what, sorry? Per asset? Okay. Okay, so the first question is, what threat model methodology did we use? So we don't have like a one box fits all type of methodology, like some people like to use STRI and whatever. So we depends on the situation we leverage some of those. But at a high level, we're trying to understand if you want to put a structure to it, we're trying to understand who are the attackers, whether they're internal or external, where the assets are, what the assets that we need to protect, how those assets can be impacted by a threat, and most importantly, a recommendation or security control for that particular threat. Into the second question, how long it takes for it depends. For most of those interview sessions, through a week, it depends on how the organization is and how segmented it is and how the application that you're trying to review. Sometimes we have people that tell us right away, oh, here's where the data is, these are the assets, these are the databases, these are the servers. Some organizations, they try to hide that. So it takes a little bit more of detective work, which is part of the process. Yeah. Yes, yes. It's everything that we do is very documented. So we have a pretty good tight project management process. So like every day we provide daily status reports and letting the customers know what we're doing and whatnot. And then once we have that finalized, yes, we provide that on the reports, all the threat model results and all that kind of stuff. So, and the funny thing about this, and I forgot to mention this, but this company actually, they claim that because of this, remember I told you that they didn't document anything. They were basically writing code on the production environments. But because of this exercise, they were forced to do it, like to tie in their controls and their structures. And they claim that they actually improved their time to market 20% based on actually having this documented. And to this point, when I talk to them and I ask for a diagram, now sometimes I see the diagrams that I gave to them early and the visual diagrams, and they updated them and they actually improving them and added more stuff that we're not able to find because we didn't get back to do another threat model at that point. Oh, so how long it takes for a threat assessment practice to be up and going? That's a good question. So for these guys, it's been taking a long time. They're still not up there yet, so I guess it took them maybe a few years to actually build something. We were basically outsourcing, but our main goal is to kind of help them out, and then once they're sustaining those activities, then we basically start to pull out so they can carry on their own. So for this particular case, it was like maybe a couple of years. Yeah. Other questions? Those are good questions, by the way. Sure.
So you have a special process to handle security-related bugs at the company. How do you distinguish between regular and security-related bugs?
Okay, that's a good question. So we do have a methodology, and this is where SAMM and what we implement is different because the devil is on the details, right? So our testing methodology is very close to what Foundstone has been doing for years. So we do have one, we follow it. And we do distinguish on our methodology security design flaws versus code level bugs. And those are the ones that usually pop out during our process. I guess we don't, based on our experience, we can identify whether a bug is a quality related issue versus a real security related issue. Sometimes it turns out to be that quality issue that turns out to be like, for example, not having the right error messages or having too much error messages logged, which actually log in sensitive information. So based on those type of things, we can able to determine. And through the process, we have a quality assurance as well through our side to ensure that we're not flagging false positives, and we're basically interacting with the developers and the senior architects to understand that where the flaws are and that we're not just coming out with ideas. Okay, one more question. Yeah. Yeah. Yeah, no, that's a good question. So the question was whether there is a methodology to kind of inform developers to differentiate between a quality bug or versus a security bug. I don't think there's something specific. I mean, it's hard because you have to be a developer. This is where I have a good position when I talk to our customers and partners because I develop software. So I can talk to a senior architect or a developer, look at the code and be able to say, hey, this is where the input comes in, this is how the input gets tainted, and this is what happens after. This is how my malicious get executed at the hardware level. So if you don't have those skill sets, yes, it's difficult. In terms of methodology, I would refer to maybe like the OWASP stuff, that a lot of the OWASP guidelines that we have. There's a code review guideline. Some of them are old. I think they have updated some of them, but I would say those are actually a good start. They provide some examples of different languages like ASP, PHP, and whatnot, the most common known languages. But I would say, yeah, inform yourself in secure architecture patterns like .NET and in Java, like using Spring MVC, all these type of frameworks, if you don't understand how those things work, it's kind of hard to distinguish between the quality box and the security box. But I don't think I've ever seen anything that is specific to provide that type of difference. Just learning how the vulnerabilities itself and be able to distinguish what they are. Yeah. Sorry, I don't know if that answered your question. There's really no like silver bullet answer for that. Other questions? Yep. Oh, thank you. Appreciate it. Thank you.